All right, let me start by giving you sort of a brief history of our company, and so you can understand how we got here. I started the company in 1996, which is 23 years ago. For the first 6 years, most of what I did was low-level geometric modeling tools. And our software found its way into products like Rhino, lots of the data translation software almost all of those guys use our software, and so on. And so we did that for a number of years, and then in 2002, I hired Dave Gill, who's our current president, as our third employee, with the goal of actually making products using our underlying geometry kernel technology. And our first products were on Autodesk 3ds Max. We were still selling those products. We also did products for Maya, Rhino, and more recently we did a product for Modo, which converted the SubD in Modo into NURBS that can be imported into a product like SolidWorks. In 2012, one of the primary guys for SolidWorks gave us a call and said, hey, can we put this tool inside of SolidWorks? And so well, I think it was 2011. In 2012, we actually previewed our product, Power Surfacing, and then in 2015, we released Power Surfacing Reverse Engineering. And so we're going to start out with Power Surfacing, and if we have time, we will go into Power Surfacing Reverse Engineering at the end. So what is Power Surfacing? Power Surfacing is basically Pixar SubD modeling inside of SolidWorks. And so we've integrated those two technologies, and the key piece that we develop is not necessarily the SubD modeling, although we think we do a really good job of that. The key piece that we've developed is the ability to convert from this SubD world into a SolidWorks surface and do it quite well, and do things like, for example, constraining the SubD to an analytic from SolidWorks. And we have a lot of customers using our software for industrial design, and we also have quite a few doing things with advanced surfacing. We have customers in a whole bunch of industries. So I'm just going to click through some pictures here real quick for you, hopefully. There we go. So we have a bunch of people doing cars. This is one of the premier, Andreas van Overbeek is one of the premier car designers in the world. And he does it all in SolidWorks. And here's Sabre Racing. You see they were even nice enough to put our logo on their truck. They do car bodies. They will like take a scan of a car and a standard stock car, and then NASCAR, and then we'll convert it into a NASCAR chassis using our software. Here is one of the world's fastest electric cars. This was designed both inside and out, and this is also Andreas van Overbeek did this particular car, and they manufactured it. It's just a prototype, and so it was done inside and out with our software, including the furniture type stuff in there. All this organic stuff was done. Here's another one of his cars. Here's sort of an example of how they put it together in the beginning. There's a Ducati mask off a Ducati motorcycle. Here's that same one at a different angle. We even have people doing fun and cool things like designing balloons with our stuff, which our stuff is perfect for. This guy even has a model, a thing where he has an octopus coming out of like this office building, and the arms are sticking out in different places. It looks really cool. Some more cars. Here's a prosthetic hand that somebody has designed with our stuff. This is another view of that hand. Here's some sort of power surfacing images that this Jeremy Lucchini sent us, And he actually went from sort of the design in the lower right side and actually ended up manufacturing the final product. Some things like furniture as well. Our stuff is real good for any kind of an organic thing like cushions and that sort of thing. Here's another amazing car. This car was actually built single-handedly by one person, and then they went and they had the body designed with power surfacing, and he put the body on it. Some more of those. And here's a guy who's done some, basically it's a half wooden car. It's reverse, yeah, it's reverse engineered. Most of this stuff, some of this stuff is reverse engineered here, but most of the cars are all designed using our stuff. And the cars are the coolest stuff, and that's what they always send us. But so here's the Sabre Racing. See the original car on the bottom, and then the NASCAR on the top. And that's it for that. So let me bring up my SolidWorks here and give you sort of an introduction to what power surfacing is, and then we'll do a little more complicated things. So one way to think of sort of the SubD world is that this thing in the middle is the sort of final result, and we can display things in different modes. Like this is the sort of the control polygon for it. This is the SubD model of it. So it's been subdivided, and we can control the number of subdivisions for display purposes. Typically we work at 3 or 4, which gives you a very nice smooth model. And you can also use the cage mode, which shows the control polygon on the outside. Now, one way to think about this object is it's kind of like a soap bubble, that these things sort of pull on that soap bubble. And as you move the cage around, it pulls towards that soap bubble. And so that's a good sort of analogy to think about it. So let me make things a little more complicated here. I'm going to grab 3 faces and I'm going to extrude them, and I'm going to say no grouping on the edges, so it gives you sort of the individual faces extruded in their own sort of normal direction. And so this now we've made it more complicated, and we've created a more complicated topology. And for example, if I extruded this one again and over and up, I could actually like create a little ring or a loop there if I wanted. So let's explore what we can do with this thing. We can certainly grab a face, move it around. We can grab edges and move them, and vertices as well. So we can select different pieces of the model and manipulate them. One of the things that is really cool is I can pick a face, for example. Well, let's pick this one, and I can change the weighting on the vertex, on the edges, I mean. So for example, at 0 weight, it's just standard Catmull-Clark subdivision, and Catmull-Clark has a technique for adding weighting to vertices, and we use the same mathematics behind that. So you can see as I increase the weight, I have sort of rounded this off almost like a fillet. And if I go to 100% of the weight, it produces a fully creased edge. So this edge is now a crease. So there will be a separate edge here. And in fact, when we get into SolidWorks, I'll show you that in a moment, you actually will be able to fillet that edge. So you can control the sort of the creasing along the edge. That's one way to sort of attract the soap bubble. Another way to attract the soap bubble is to insert additional edges. So I'm going to hold down on the A key, which is the insert loop key, and you can see it shows the loop where it will be inserted. And so if I click right there, I've inserted an extra loop in here, and you see now I have 2 edges that are close together that are attracting my little SubD soap bubble thing, and you can see it's a much more, it's much less rounded, and it's getting closer to looking like a fillet. I can do the same thing on the inside, where I do a, it's called an offset loop. And so I'm just going to offset this face, and so I've added a loop inside of that face. So you can see that there are different ways to do that sort of thing. I can select, if I double click on the middle of an edge, I'll select a ring, which is a ring around here. If I double click like the end of an edge, we'll select a loop. So a ring is the ends are not connected. A loop is like a connected set of edges. So let's do this, and then we can use the other major tool that we often use in subdivision is insert loops. And here we can control the number of edges that we insert. We can also control sort of where they go along it, so we can push back and push forward with them. We can also control the pinch in or pinch out. So pinch in or pinch out on that. So that's kind of the basics of the insert loops tool. And so let's take a look at let's convert it right now. So let's convert it and take a look at what it looks like in SolidWorks. Okay, here's the SolidWorks model, and this is basically it's a nice solid, and so we can do all the sort of solid modeling operations that we want to do with it. For example, I can grab this face and I can say shell, and I think we need to go pretty small on that. So let's try that. Let's show preview, see how big that shell is. Oh, that's kind of small. Let's maybe go like 3 or something like that. Okay, so we were able to shell it. Actually, let me make the shell a little bit bigger. We can edit that. Let's go 10. Okay, I got it a little too big. Maybe let's go try 5. Okay, actually it did work. It was warning us because probably the radius of curvature up in these areas is bigger than the radius of 10, but obviously SolidWorks was able to handle it in this case. So, and I can grab an edge and I can throw a fillet on it. All right. Now that we have these SolidWorks features on here, we can still go back into this guy and change things around a little bit. You know, for example, we can sort of change the shape. And then when we're done, it'll go ahead and reapply those features. So you can see it works very well within the context of SolidWorks features. And we can, you know, shape these things however we want. And there's a bunch of videos of, you know, what are the different ways to do that. Let me take these off here for now. And then I'll show you some of the other things inside it before we go. Oh, say yes to delete those features. Okay, so let's go back into here. And let's pick this face. And what we want to do here is I can use this mirror tool to create a mirror of this thing. So now, if I grab this, you can see that it's working on the mirror. Now our little gizmo thing here is pretty cool, because with our gizmo we can do pretty much anything you want at a given time. And the gizmo is sort of intelligent. It always reorients. See how it's reorienting itself towards you? So it makes it very easy to pick the gizmo. And if it's lined up kind of along the axis, you notice you don't see the other, you know, the Z direction gizmo here, or yeah, I think it's the Z direction gizmo. You just see these two. And so it's pretty handy that way. You have the rotation capabilities, with these rounded arrows, which is pretty standard. You also have the ability to move in a plane. So as I hold over this one, that says I'm moving in the X and Y plane. And this one is scaling in the X and Y plane, so you can scale up or down in the X and Y plane. And then this one is the middle, actually scales in the X, Y, and Z plane, which won't have any different effect because there's no Z component in this one. But if I grab some other pieces, you would see that it scales in the Z plane as well. And then you can scale the individual axes as well with these arrows. So you can scale and move one axis at a time. So that's the mirror and the gizmo and how that works. And so it's very flexible in terms of moving things around, creating organic shapes and that sort of thing. So often we run into a case where we need some extra detail, but we don't want to put it at this level. In other words, we want to add, let's say we're making a handle or something. Let's extrude this again here. And oh, that's a crease there. So I'm going to make that smooth now so that you won't see that edge there. So let's say we're making a handle or something, and we want to add some grip stuff to it. And so we can use the LOD. Let's go to LOD2. And what that's going to do is that's going to basically put two subdivisions on it. And so let's grab some edges here, or grab some faces. Oh, I know. Let's see. Let's grab some vertices. Okay, then I'm going to move these vertices out. Move down here. Move those vertices out as well. So I've added some detail and can do a similar thing on the other side. Maybe I just want to move one vertex out so that you can put your thumb on that. So the cool thing about this is that what we've done is that we have, when I go back to and turn the level of detail off, those details still stay in the model. And they're embedded in sort of a magic table, we call a subdivision table. And it is cool because what it allows you to do is, okay, let's grab a few of these things here. Let's grab that. Yeah, this one's good. If I move and rotate, let's say I rotate this around, you can see that this relative shape of this face stays the same. And so you have the ability to kind of manipulate at a high level and a low level using the level of detail tool. And so it's a pretty interesting way of working with things. So let me, so that's kind of the basic SubD modeling. Let me show you how things interact with analytics. So I just read in a simple cylinder, and so this is a basically extrude of a circle, and then I'm going to create something here, and I'm going to line it up, maybe scale it down a little bit so that it's about the right size. And I'm going to delete that face. And I also probably, okay, let me, so I can always import surfaces from SolidWorks. So I'm going to grab this outer surface for now. And you can see it comes in here as yellow. And if I can go into this guy actually and say, so I can turn that off. So now I can see through it. And so typically what you want to do is you want to get this guy kind of close. It doesn't have to be exact, but you want to get it kind of close to where you want to constrain it. And so we're just going to say constrain to an edge. So what we've done is we've constrained that surface, this SubD surface, to the edge. Now let me make a little something more in here just to make it a little more interesting and complicated. Okay. So now we have this shape connected up here, and we can control what happens along these edges. So right now it is tangent to the cylinder. And so if I go into override constraint, I can say no tangency. So you see we've lost our tangency there. I can say perpendicular to surface, which in this case doesn't make a whole lot of sense, but you can see what it's doing. In some cases you want that, in some cases you don't. And we can also do curvature continuity as well, which will give you a G2 continuity between the surfaces. But let's go back to tangent to surface. The other thing that we can do is we can control the strength of the tangency. So here I'm making the tangency very strong, and as I pull back, and go to 1, I'm making the tangency weaker. So you can kind of control how strong your tangent is. You can also control the angle of the thing. So it's not really tangent now, but based upon that, you're controlling, you can control the angle. So if you say, well, I need it like 3 degrees for a draft off that or something so I can manufacture it, you can do that. So let's go ahead and say we're done with that. And then we can convert it to SolidWorks. And if I turn this back on, I want to pull up here. So what I want to do is I'm just gonna delete this face. Insert face, delete the face. So I'm making it an open shell. And then if I pull back down with my power feature, I should now be able to tools, surface, knit, and I will try and create a solid. And you can see we now have a nice solid here. Now that was a nice, easy way to connect. The other thing that we can do is we can connect on a face, not just an edge, but we can connect on a face as well. So let's try and look at the creep. Let's make a box again. And here I'm going to delete this bottom face. And I have to import the reference again. Oh, I'm going to hit the button actually. So if I decide I want to go over here, I could always pick these surfaces as well. Say good. I'm going to grab those edges and I can say to face. And so then we have it constrained to the face. It's still a little bit hard to see. So, if we went down here, we could turn off the surface knit so we could see what's going on. And one of the cool features that we've added in this is the ability to convert and do an automatic delete and knit. So what that's going to do is it's going to delete that surface from the model, sew things together, and knit it all back together into a solid. So when I say that, it automatically, got to turn it back on. It automatically created 2 extra features on the tree. One that deleted this face from the previous knit model, and one that knit this whole thing back together so that now it's a single solid. You can see it right there. So let me kind of take you through a couple of models and show you how we can use it to produce something, use these techniques to produce something much more interesting and much more realistic. This is just kind of the play demo thing here. So here's a drill that we did. It's an electric drill. And so what we've done is we modeled sort of the, this is a typical sort of scenario here where, we have an interface here where the battery goes, which is, has to be a precise size. And then we have the chuck on it, which also has to be of a certain size. And then the rest of this is going to be organic. And so the first part is this part of the body right here. And I'll just edit it and you can look at it real quick. Basically, all it is an extrude, a box with 2 extrudes on it, and then it's been shaped. So it's fairly simple model. And then we constrained it to this cone. And if you actually update the cone, which I didn't show you in the other model, but I could have updated that cylinder in the previous model, and it would have updated the corresponding SubDs. If you have a power feature, it automatically maintains those relationships. Okay, so let me move down to the next part here, which is the base. So the power feature base is a little more interesting because it's still like a box, basically. It's a little box. It's been shaped, but it has these edges which are creased. So if you pick it, you can see the edge weight is 100. So that was necessary in order to align correctly with the bottom plate. The bottom plate has these creased edges in them. So this allowed us to put it on the bottom plate. And let me go out of here and you can see what we've done next. And then we knit the 2 of them together, and then we did a fillet. So we were able to fillet these, just like you normally would any SolidWorks surface. And then we put the handle on, and the handle was very interesting because to make the handle, we had to connect up to both these surfaces and these surfaces. And if I edit this, we'll take a look at what's happened underneath. Okay, so here again, it's a fairly simple, from a topology standpoint, a fairly simple model. And we have imported, some surfaces from the other SubD on the top, and we've imported some surfaces down here. Now, the cool thing is that because this is all filleted and tangent, that I don't need to have like an edge break in here. So you can see that this guy flows, this edge kind of flows over that fillet. So you can see now it's inside on just this surface. And then if I pull it back down here, you can see it flows right over that fillet edge because it's tangent. You can see this one does as well. So as long as they're tangent, you don't need to have a break. If you had a creased edge here, you would in fact need to put one of these brakes on there and deal with it slightly differently. But that's sort of an atypical sort of situation. And you can see up here we've put some partial creasing in to prepare for the, so that's like a 50% crease to prepare for where the trigger will go. So this is sort of an example of industrial design. You know, you could do this fairly easily with power surfacing, and yet trying to create this model within, and you can see here, let me pull down, that there really are not a lot of features in this feature tree. You know, if you had to do that with surfacing, this would be a very, very big feature tree. And so I think that is also one of the great strengths of our stuff, is that the feature tree stays fairly simple. You can create these wonderful surfaces, these organic things that stick together. They don't fall apart. Like if you're using surfacing and you modify something, you may have to reconstruct a whole bunch of different surfaces. So that's one of the great advantages of it here. And so we're just about out of time. So let me just bring in one quick example and of a surfacing problem that we've dealt with, and then we'll open it up for questions. So here's an example of a surfacing problem. This is a bike we've got from a customer. I'm not going to show you the rest of it, but basically what we've done is we've created a blend between the, you know, this is the front of the bike, and we've created this surface to blend it. And so it's a relatively simple in terms of SubD, but you can see how complicated it was to blend those. And it's very, very difficult to do anything like this with surfacing. But with SubD, this is like, it probably took me 10 or 15 minutes to put this whole thing together. And so that's, you know, that's really the sort of a strength of SubD, is being able to, you know, okay, I got this surface, I want to make these tangent here, and you notice they're not tangent on the top, but they are tangent on the sides, and so on. And so it was a fairly easy construction. I basically created a box, split it, and extruded a couple things and modified it and inserted a loop here along here, and then that was it. And I think it's mirrored as well. You can see the top edge is probably mirrored. So, all right, so that's all I have for now. I could go a lot longer, but I think it's time to open it up for questions.
Great, thanks, Gary. That was great. Sure, so we can open it up for questions. If you guys have any questions, feel free to just type it out here in the question box, and I will pass it on to Gary. While we get our first set of questions, Gary, if you could just let us know or give us a little better understanding of power surfacing, what's difference in reverse engineering in that module?
Power surfacing does not take like a scanned mesh. Let me show you some of the things real quickly that we've done with RE. So sometimes you want to build on top of something that's already existing, like you do a scan or you have a ZBrush model. And so you can import the scan and work with that. Okay, so let me just quickly go through and show you some examples here. Okay, this is the sort of model that you get. I think this is originally a ZBrush model, and we've been able to within a matter of a minute or two, reverse engineer it. So these are all models that we've brought into SolidWorks. And we can even handle super fine detail. So I believe this is a scanned mesh. If I'm not mistaken, this is definitely a scanned mesh. And you can see we can pick up an amazing level of detail from the mesh because of the way our tools work. So that's sort of the basic overview of it.
Okay. That's good. We've got a question here. If you had a 3D scan of a complex geometry, would you be able to clean up the surface and modify if you needed to?
Absolutely. That's what the rest of this presentation I'm showing is all about. So
okay.
We have no other questions. I can, I can go through it really super quick.
We don't have any other yet.
Okay. Okay. So the basic process is that we can read in a scan mesh, and we can do a quad wrap, which puts a bunch of quads around the outside of it. And then we can take that and we can shrink wrap it, which is sort of like, when you have a plastic bag and you suck the air out of it, and we can shrink wrap it to different levels to pull out much more or less detail. So this is with no shrink wrap. This is level 1, level 2, and level 3. You can see at level 3, we've gotten basically all of the detail from the mesh into the result. Okay, here's an example. Here's sort of an example of doing it. So you can quad wrap at different levels. Like 4 is probably a little too big. 1, that's super fine. We can probably do it a little higher than that. Like 1.75 is sort of ideal. And we go into SubD display mode, and then we do the shrink wrap. And when you shrink wrap it at level 2, if you watch it, you'll see that it gets much better detail. And then we can convert it to SolidWorks, and there's your resulting surface breakdown, and it creates a valid solid there for you. And you can also apply features to it. Here we're, cutting the bottom and putting some features on it. One of the cool things about it is that we have the ability to create different level of detail on the model. So areas which are smooth have a very low level, like level 0, and then level 1 is like slightly more, and then the blue areas is where you need a lot of detail to capture the curvature. Here's some real-world meshes, the worn or damaged areas in the original object, 3D anomalies, like microscopic holes are bubbling, a thin razor edge, and a false bridge, and we can clean all of that stuff up. One of the ways to clean it up is to directly edit the original scan. One of the things that's unique about our stuff is we can edit the quad wrap to retopologized mesh. And usually option 2 is much simpler and more efficient because you're dealing with nice quads and it's real easy to do things. So I'm going to skip this one here actually. So I'm going to, okay, no, actually that was the one I wanted to play. Hold on. Okay, here's how to clean it up. So we've done the quad wrap, and sometimes you can just fill the holes. And so here's an example where we have like some bubbling going on, like a little teeny hole there. And so we fill it up, and here's one of the bubbled edges that the scan is not real good. So we'll just delete that area. And you can see how quick and easy this is. Can you imagine trying to fix up that underlying mesh and get a nice shape like this? So this, you can see how we've been able to create a nice edge there. Here is that razor edge sticking out. And so we have various tools to go and really quickly clean up these quads. We have this quad fill tool, which kind of automatically fills things in, which is that one right there. That's one of my favorite tools. And you can see we've reintroduced the edge. And so we can, do things like this where we take an area where, oh, it didn't quite get up into the thumb. and clean that up as well. So we just deleted it, and then we're going to subdivide that, subdivide those edges, and then quad fill it to get the level of detail. So that's sort of an example of, you know, filling things up and cleaning things up. So here's some examples of some sort of mechanical stuff that we have. Figurines. We actually went to the Toy Fair show. We have customers like Hasbro and Disney who use our stuff to convert figurines and complicated things like that into SolidWorks models. You can do architectural stuff, medical, industrial, you saw that model before. We can even do topology optimization, where we quickly wrap up the topology thing. I'm going to skip that one for now. We can do ZBrush sculptured meshes. Now, the typical workflow for something like this, let's see if I can get to one of our, yeah, is that the toy company will send a STL file from ZBrush over to China, and it will take a matter of weeks for them to redesign it in CAD. With our tool, they're able to take that same model and within a matter of a few minutes have a suitable CAD model to work with all of the detail. One of the problems is when they send it over to China, you know, if we could see this guy's head here, yeah, there we can see it here. When you send it over to China, if you can see my cursor, there's a little dimple, a little mole on the side of his cheek and a little dimple on his chin. And Disney will not authorize this model as Luke Skywalker unless it has those details like that. And so what happens is a lot of times they'll send it over to China, have it redesigned, but it's not good enough. So they'll have to say, oh, you need this and add this and so on. Whereas our stuff, you're able to pick up all of these fine details in the very first conversion of it. And you don't have to send it to China and spend a bunch of money on it. So, so that's kind of an overview of the RE stuff. Any other questions?
That's really good to know, Gary. We've got one final question. Do these surfaces also export a pre-configured render-friendly UV mesh?
Okay, say that again. Was that a question?
Yes. So it says, do these surfaces also export a pre-configured render-friendly UV mesh?
In as much as they're turned into SolidWorks surfaces when they're done, and you do have some control about the surface breakdown. Like you can grab a set of quads and say, I want this to be a single surface. So yeah, it's basically you know, a SolidWorks surface. So whatever you can do with SolidWorks surfaces, you can do. So it is a UV friendly sort of scenario there. So right. It's almost as if you designed it with SolidWorks surfacing. It says NURB surface. So.
Okay, great. I hope that answers that question. And yeah, we've got another question asking where can we find tutorials for these tools? And would you get a copy of this webinar for future reference? Yes, we are recording this webinar and we will be shortly publishing this. So we'll have this over YouTube and we are happy to share that link with you guys. For the tutorials, Gary, anything that you would like to offer?
We have a bunch of stuff online in our YouTube channel, and you can get at most of them from our website. And we often will do, you know, if somebody has a particular problem that they don't see addressed, they can simply contact us, send us a model, and we can say, okay, here's how we would solve this problem, and give them a demo and show them, okay, here's how we would do this, and go from there. And we do that almost once a week for a potential customer. They'll send us something and say, okay, how do I design this shoe? And they'll send us a scan, or they'll send us a CAD model and say, how would I do this? And so we'll show them, and then we'll show them the tools that they used. So that's actually a pretty good way to do it. And we'll also, typically while we're doing that, we will give them sort of some of the rules of thumb we use for design. For example, use as few control points as possible. And then as you need detail, you add more. So you start very low and you add more. And you saw most of the models here did not have a whole bunch of, quads in them. The power surfacing ones were fairly simple. And then we would just add detail if we need it.
That's great. Thank you. All right, then. I think we got to wrap up this webinar. Thank you so much, Gary, for this. It was really informative.
You're welcome.
And any of you guys, if you've got any questions, feel free to reach out to me personally, send these questions through, and I can get in touch with Gary to get them answered for you. And if you've got anything in regards to the commercials, we are your single point of contact for this anyways. So thank you everyone for joining in, and thanks a lot, Gary, for presenting all of this.
Well, thank you for reselling our products. It sounds like you guys are doing a great job. So
thank you so much.
take
All
care.
right.
Bye.
Thank you. Bye.